Right. These are the lessons that we have covered up to now today. We have covered ICT fundamentals as well as the data representation. Then the logic gates, Boolean algebra, operating systems. And actually, we need to do this one. Today we have to start this lesson, the operating system lesson. Or we can start the word processing lesson. One of these because I wanted to discuss the summary of logic gates last day, because I said that we have already covered logic gates, but I'll be doing that. So I have to rethink about that. So, okay, let's do that with some exercises, right? Because I have planned to explain the lesson from the beginning to the end, but with this situation, it's a bit difficult. Anyway, I'll be covering that. That means I'll be revising this lesson with some exercises very quickly. Okay. To do the exercise with me, you can use this online tool. That is logic.ly/demo. So please log into this interface. It's a bit easy to do the practical using this. Right, since we have discussed the theoretical part, in case if some of you missed that theory, I recommend you please go and look at the videos. But anyway, I'll give you the note and all to study, but better you can go and study those videos back, because we have already discussed this lesson. So this is the link. I have already sent that, and I'm resending the link, logic.ly/demo. I have resent that as well. Okay, the next thing is, in addition to this, please open this in another tab. This is very basic online tool. Which is given for kids by Colorado University. But this is also important. And there you can go to the lab, this one, lab. And that link also I'm sending to you. Open that in a different tab. Please open that in a different tab. Please send in the link, open that in the different tab. In this lesson, logic gate, we have learned about 3 basic logics. Actually, what is a logic gate? Simply tell me, what is a logic gate? So what is your idea? What is a logic gate? Yes? Aniti? Yes, Sandhu? What is a logic gate? Logic gate is what? Yes. Please support me, Pute. I said that it's very difficult to me to talk. Can you remember? So what is a logic gate? Logic gate is what? Okay, I'll do that then. Logic gate is a logical behavior which explains logical behavior of electronic circuit. So electronic circuits behave different ways. Electronic components are behaving different ways. These logic gates are used to explain these logical behaviors. So one behavior is called, yes, there are 3 basic behaviors. Can you remember? So what are the 3 basic logic behaviors or logic gates? Am I audible? Can you hear me?
Yes, sir.
Okay. So what are the 3 basic logics available, or 3 basic logical behaviors?
AND gate, OR gate, NOT gate.
Exactly. AND gate, OR gate, and NOT gate. Right. So let's see the logic behavior first using some circuit demonstration, right? So let's say you have a battery and wire connected to this battery and bulb as well as a switch. So this is the basic circuit. This has actually no big logic. This circuit has simple principle. When you turn on the switch, it will turn on the bulb. Turn off the switch, it will turn off the bulb. It's very simple. On karat on venom, off karat off venom. That is very, very simple. But logics come when there are more than one switches, especially when there are more than one switches. We have to think what will be the logical behavior. Okay, let's think there are two switches like this. If you want to turn on the bulb, what you need to do? Let's name these switches as A and B. Switches A and B. If you want to turn on the bulb, what do you need to do? Yes, Dimat? Okay, Tisu. Bulb එක on කරන්න අපි මොකද කරන්න ඕන පුතේ? If you need to turn on the bulb, what we need to do? A switch එකයි B switch එකයි දෙකම තියෙනවා. A වැහුවොත් bulb එක on වෙයිද? Dimat?
No, sir.
No. B වැහුවොත්? If you close B?
No, sir.
A and B both?
Yes, sir.
Yes. So that is called the AND behavior. AND behavior. If you close A and B both, then the bulb will turn on. So that is called AND behavior. So AND behavior, so that can be applied to any number of switches. These switches can be treated as inputs. So this can be applied to any number of switches. Means if you have 3 switches, you need to turn on both, not both, all A, B, C to turn on the bulb. That is the AND behavior. A and B and C. All other occurrences, it is turned off. So only possibilities, okay, let's say all are 0, turn off. This is 1, turn off. Then this is 1, turn off. This and this, turn off. Then this only, still turn off. This and this, still turn off. Then this and this, still turn off. 1, 2, 3, all, then only. So that is the logic behavior. That is called AND behavior. The symbol for AND gate in logic gate, the symbol for AND gate is like a half pendulum. Half a pendulum, right? It's like that. Okay, this is what the AND gate. You can see. Right. Yeah. It's there in the basics. Here it is. And if you have 3 switches, A and B and C, so this is how you represent. This is called Boolean algebraic notation. Boolean algebra notation. This is called Boolean algebraic notation. A and B and C. All 3 must be 1 in order to get 1 from AND gate. AND gate taking 1 gun. 1 may know. Okay, here you can see, right? Can you feel this? So if A, B, C all 0, what about A and B is 0? A and B and C, is it 0 or 1? Is it 0 or 1?
0.
0. Actually, which will produce 1? Which occurrence will produce 1?
All A, B, C are
Yes.
1.
All A, B, C. This one. A, B, C, if all are 1, so this will become 1. For sure, this will become 1. So you can write 1. That is the only occurrence. All other occurrences, it is 0. Here 0. Here 0. Here 0. And here also 0. So it's very simple. If all are 1, this is 1. That's all. That is your AND gate. And here, okay, what about A and B? A and B, then it's considering only A and B. So that means this part. So you have to find out occurrences where both A and B 1. Here no. 0, here no. Make it B0 in the back. Here also A and B 1, right? And here also A and B 1. So you can say this is 1 in 2 occurrences, this way and this place. It is 1. All other places, it is 0. Are we clear on AND behavior? Are we clear on AND behavior? AND behavior ගැන අපි clear නේද? හරි නේද? AND behavior කියන්නේ ඔක්කොම එක නම් එකයි. සහභාගී වෙන input ගාන 10ක් තිබ්බොත් 10ම එක වෙන්න ඕන. If there are 10 inputs, all 10 must be. If there are 2 inputs, all 2 must be 1. Both must be 1. If there are 3 inputs, all 3 must be 1. So that is the AND behavior. Symbol for AND gate is this. This is 3 input AND gate, and this is how you can create AND gate using 2 input. Input දෙකක් තිබ්බොත් AND දෙකක් සම්බන්ධ කරන්න මෙහෙම. If there are 2 inputs, මේකේ තියෙන දෙකයි A and B. P is equal to A and B. Then P and C is, you can write like this, right? This is this you can P equal, you can say this is A and B row. So then this part you can write P and C, right? P and C. P here, C here. But actually P and C is equal to A and B. No, P means A and B and C. P here, C here, P means A and B and B and C. So therefore, similar output can be taken using two input gates. Similar output can be taken using two input gates. Okay, that is the AND gate behavior. I think we are clear on this. And if you want to see this practically, so please use this one that I said. Go and drag AND gate. You can change the number of inputs here. 2 input, you can say 2, 3, 4, any number. So then if you want to see that, use switches, this toggle switches, 3, 4 toggle switches, and let's connect them together. And then just connect a bulb to see the output. And you know, this will only output when all A and B and C and D are 1. So when you select and draw a truth table for this, you can see it will produce true when all are true. ඔක්කොම true වෙද්දි තමයි true. නැත්නම් ඔක්කොම 1 වෙද්දි තමයි 1. True වෙනකොට 1 දාන්න පුළුවන්. අනිත් හැම අවස්ථාවෙදීම all other there will be 16 combinations. Because there are 4 inputs. Right? How to get that? 4 inputs will give you 16 combinations. Actually, that is how we are taking 2 to the power 4. 2 to the power 4. That is how 16 comes. In the 16 combinations, all other occurrences it is 0, but all are 1. When all are 1, this will output. Okay, that is AND behavior, right? So let's quickly learn OR behavior. So if you have doubt, tell me. Now I can answer. If you don't have doubt, let's proceed to the next one. මොන හරි අපහැදිලි තේරෙන්නේ නැති තැනක් තියෙනවා නම් කියන්න පුතේ ඔහොමම. එහෙම නැත්නම් අපිට ඊළඟ එකට යන්න පුළුවන්. If anyone cannot understand, tell me. මම සිංහලෙන් කියනද මට තියෙන ප්‍රශ්නේ. මම මේ සෑහෙන අමාරුවෙන් කතා කරන්න පුතේ. It's very difficult to me to talk. I'm tired වැඩි කතා කරද්දි. ඒ ඔයාලගේ ක්ලාස් එකෙන් පස්සේ තව 11 පන්ති දෙකක් තියෙනවා. එතකොට මට ගොඩක් tired කතා කරද්දි මේ COVID issue එක හින්දා. ඒකයි මම ඔයාලට කියන ඔයාලත් පොඩ්ඩක් කතා කරන්න. ඒතර මම කතා කරන්න ඕන ප්‍රමාණය අඩු වෙනවා. තේරුණාද?
ඔව් සර්.
හරි අපහැදිලි තැන් තියෙනවා නම් අහන්න. එහෙනම් ඊළඟට යන්න. OR gate එක, when it becomes to the OR gate, the connection is not serial like this. The connection will become parallel. OR gate connection is parallel. Let's say you have 2 switches. These switches are connected in parallel way, like this. Here also I can connect this parallel to the bulb. Okay, now let's say I want to turn on the bulb. So what are the options? If I turn on this switch, will it turn on the bulb?
Yes, sir.
Yes. Because circuit is complete, right? Loading complete. Therefore, the bulb will turn on. What about this one?
Still yes, sir.
Yes. Because this is again complete. Both, still. If you turn on both, still, it will turn on. But if you turn off both, they come in karo. If you cut both lines, then this will turn on. So let's add another one. You can add any number of switches inputs parallelly. So to show the and O behavior, any number of make on karat. May I on karat? Here, yes. Dekak on karo, it. May I on karo, it. May I on karo, it. Punam on karo, it. So only possible way to turn off bulb is disconnect all three switches. So O gate behavior is where all these switches, all these inputs are zero, the output will be zero. ඔක්කොම බිඳු වුණාම බිඳුවයි. AND gate එක ඔක්කොම එක වුණාම එක වුණා. O gate එක ඔක්කොම බිඳු වුණාම බිඳුවයි. O කියනකොට මතක තියාගන්න. O ලියන්නේ මෙහෙමනේ O gate. O gate ලියන්නේ OR කියලා ලියන්නේ. එතකොටම ඔයාලට එක්සෑම් එකේ මතක් වෙනවා බිඳු ගේට් එක ගැන තමයි මේ කියන්නේ. ඕනේ. O කියන්නේ නිකන් බිඳු වගේ. බිඳු ගේට් එක. So O it O looks like zero. O gate. Zero කියන එක මතක තියාගන්න. Zero gate වගේ නිකන්. Zero O. Then if all are zero, ඔක්කොම zero නා. Zero කියන්නේ මේක zero off, මේක zero off, මේක zero. If all zero, this is also zero. ඕක තමයි O gate එක. If all are zero, output is zero. එහෙම නැති ඕනම වෙලාවක output එක එකයි. එහෙම නැති ඕනම වෙලාවක කියන්නේ how many other occurrences are there? තව කීයක් තියෙනවද මේ බිංදු 3යි ඔක්කොම කී පාරක් කීයක් ලියන්න පුළුවන්ද? There if there are 3 switches, how many combinations? Yes. Switches 3ක් තිබ්බොත් combination කීයද? How many combinations? Input combinations?
8.
8. There will be 8. දන්නවනේ ගන්න විදිය නේද මම කිව්වේ කලින්. 3 switches නම් 2 to the power 3. දෙකේ තුන්වෙනි බලය. දෙවරක් දෙක. දෙවරක් දෙක 4 හතරක් දෙක 8. There will be 8 combinations. 8ක් තිබ්බට 8න් තුනම බිඳුව වෙන විතරයි වෙලාවට විතරයි බිඳුව. අනිත් 7ම එකයි. Okay, let's see. Okay, you can see the diagram here. If both are open, off. Both are 0, 0. Otherwise, 1. දෙකක් තිබ්බොත් 4යි. දෙකේ දෙවෙනි බලය. තුනක් තිබ්බොත්. There are 3. If there are 3, right? So can you draw the truth table for 3, please? Use a separate paper or rough sheet and draw here. Truth table for this, please. And the Boolean expression, both Boolean expression and truth table. You can send it to the chat, please. Create the truth table as well as Boolean expression. Send it to the chat. Okay, let me draw this, but I really need you to do this, right? But අපි හිතමු truth table එකේ තියෙනවා මේ පැත්තෙන් ලියන්න හරි A තියෙනවා B තියෙනවා you have A B C gap එකක් තියලා A B C. Then the output is A, O, B, O, C. And finally, you have to fill this truth table. This is the input, this is the output. Inputs. So we have a short way of writing 8 inputs. So please note that you can write like 0, 1, 0, 1, 0, 1, 0, 1. Then the second one, 00. Okay, Dimat, correct. Dimat, antimek balan kotta. Last one. Check it. 0, 0, 1, 1, 0, 0. හරියට කරන්න exam එකේ නැත්නම් වරදී දිනවා. හරිද? මොකද paper එකේ කියන්නේ නැහැ paper එක අනිත් පැත්තට කියන්නේ මේ අන්තිම වාක්‍යව බලන්න දීමක් කියලා. Right? So be careful when sending the answers. So the first one is 0, 1, 0, 1, 0, 1, 0. The second one is 00, 11, 00, 11. Third one is 4 zeros and 4 ones. That is the third one, right? So this is the input part of the truth table. The output part you already know. Output. So what about the OR gate? OR gate will output 0. In which phase? OR gate will output 0 only one time. Which time it will output 1? Yes, sorry, 0.
When all are 0.
When all are 0, correct. When all are 0, 0. All other occurrences, it's 1, 2, 3, 4, 5, 6, 7, 8. So it's very, very easy. So this is the truth table. If you have not done, please fill it. So this is how you are doing it. And so better if you can draw lines of the truth table also. Yes. Please complete it as a table. Okay. Right. So AND gate truth table. AND gate again. So shall we add the AND gate component also? That is AN, BN, C. So that is how you write the Boolean algebra notation, right? So Boolean expression kya. So that is, this is A dot B dot C. Here A plus B plus C, right? Here A dot B dot C. So the output will be, so in all are 1, it is 1, no? So it is 0, 0, 0, 0, 0, 0, 0, 1. This is same, mummy. This is not the activity. I have expanded that to show AND gate also. A and B and C. So A and B and C is equal to this one, right? You can write A and B and C this way also. A and B and C. A, B, C without any spaces. They are writing A, B, C adjacent way like this. So that is also AND gate. A and B and C. Okay. Right. Then the NOT gate, that is very simple. Right? Implementing NOT gates, very, very simple. NOT gate is basically inverting the output. Whatever the output you are getting will be inverted. So here they have given resistor with like this is a very heavy resistance, and there is a switch as well as there's a bulb. And when you when you keep this as it is, you can see the bulb will turn on, because even the resistor is there, the power will go through the resistor. අමාරුවෙන් හරි මේ resistor අස්සෙන් ring එකගෙන යනවා ඉතින් current එක යන්න තැනක් නැහැ නේ. Since there are no other place to move the current, so it's very, even though it's very difficult to move through the resistance, it will anyway move. But when you short circuit, what will happen? When you short circuit, so then this will turn off, right? That is the idea. I can make a the on inverting. Inverting means when you when this is 1, output will become 0. When this is 0, output will become 1. Yeah. When it is 0, output will become 1, and when it is 1, output will become 0. It's like trip switch. When power is there, the trip will turn off. Power is not there, trip will not. So these are the things. Okay, then the combinational logic gates, how we can combine to create the other gates. O combined with NOT gate, we call NO gate. First you are sending to the O gate and combining that with NO gate. So I'll tell you another thing. So can you check whether both of these are same or different? I'm drawing another one. Can you send me, so this is like A, O, B, no? So let me draw another one. Take A is there and B is there. Say same A, B. Then let's add A is there, B is there, and let's add I need O gate. How can I have O gate? Annotation will not help me. Then what? Okay, let's draw something. And let's have this with white color. Go like this. This is AND gate. I want this to become O gate actually. Okay. Let's go this. Yes. Right. Good. It is okay. Right. Let's see. You have gates like this, and I need a triangle too. That is my NOT gate. Let's draw it red color. I have 2 NOT gates. This one NOT gate, and this is another NOT gate. And beyond, then the wires in also. Okay, so I need you to compare the truth tables, and so please draw, please write the Boolean expression and also send me the results of truth table for the gate here. Right, you need to send both Boolean expression and also the truth table. For this one, you already have the Boolean expression is there now, only the truth table. So I'll number these. So this is number 1, and the second one is number 2. What you need to do? Number 1, please send me the truth table. Number 2, please send me Boolean expression and truth table both. So please do this now. Please do this now. All right, first one, answers, right? Yes, 2 inputs can 4 combinations. So first one is 0, 0, and then this is OR gate. Yeah, then NOR gate. Second one, is the problem. First one is okay on it. Your answer is correct. The second one is wrong. So please check again. Please check again with the second one. So something went wrong in the second one, but the first one is correct. Yes, how can we do this? Right, first of all, you have to write this carefully. So understand. So if this is A, if this is A, and if this is B. So can you tell what will be here in this arrow point? This will be A not, right? This is A bar or A not. So what about this point? This is B bar or B not. So A not, B not, and this one will be A not. Since this is OR gate, O B not, A not or B not. That is the Boolean expression. That is why I said your answer has some concern. So that is not correct. A not or B not. Okay. Okay or not? Arida තේරුණාද නැද්ද? First you have to not make වෙනස ඒකයි පුතේ. Here you have to O first. ඉස්සෙල්ලා O කරලා මේ O වෙන මුළු එකම තමයි not වෙන්නේ නේ. So A O B everything will be not. මේක මෙහෙම ලියන්නත් පුළුවන්. A O B වෙලා එන output එක තමයි not වෙන්නේ කියලා මෙහෙම වරහනක් දාලා පොඩි මෙන්න මෙහෙම not එකක් දාන්නත් පුළුවන්. අර අනුපූරකේ දාන්නේ exponent. Sorry, not exponent, like the complement. A or B not කියලා දාන්න පුළුවන්. chat එකේ වලකට එහෙම කරා නම් හරි. A or B not. මොකද A bar එවන්න බෑනේ chat එකේනේ. Here first A or B, then A or B everything not. But here A will inverted first, B will inverted again, B will be inverted, A will be inverted. After inverting only it will become one. Understood or not?
Yes, sir.
Okay. Now can you create the truth table, please? Can you create the first one? I'll help. First one I'll help. I'll write it here. Since there are two inputs, you have A, B, A, B, A O B, then A O B, everything not. Okay, see, this is the truth table for the first one. And let's do this 0, 1, 0, 1, because there are two inputs, can 4 combinations. Here it will be 0, 0, 1, 1. I hope this is clear to you because we have already done that. And A or B is OR gate, you know. OR gate, if both are 0, it is 0. Both 0 and 0, OR gate. Both are 0, the output will be 0. Dekama binduwa na output එක 0. Otherwise it is 1. 0 and 111. This is the output. And then the inverted output. ඊට පස්සේ දින invert කරාම. Invert කරාම මොකද වෙන්නේ? The inverted output, let's see. Okay. The inverted output will be 1, 0, 0, 0. That is the inverted again. මේ තියෙන එක invert කරා. 1, 0, 0. Okay. You can draw this and now at least send me this now. දැන්වත් මේක වන්න පුතේ මේ දැන් මම කිව්වනේ කරන විදිහේ A not, B will become B not, then A not or B not. Actually, this is this one is previous. Okay, send it now, please. Right, what do we need to enter there? A not. A not is, yes, if it is 0, 0, 1, 1 here, that should be 1, 1, 0, 0. That is clear. So it's clear enough. 1, 1, 0, 0. That is reverse of A. A is 0, 0, 1, 1 here. Please study. A is 0, 0, 1, 1. So A not is 1, 1, 1. That is the reverse. B is 0, 1, 0, 1. So B naught is 1, 0, 1, 0. That is B naught. Then O. What you need to O? O karannona mokadda? You need to O this and this. The speciality of O gate, dekama bindu nam bindu. Eka tama O gate එක විශේෂත්වය. අනිත් ඔක්කොම එකයි. මේ එකක් දෙකක් තිබ්බත් එකයි, එකක් තිබ්බත් එකයි. මේ දෙකනේ දැන් අපි ගන්න ඕනේ. We have to consider these two columns, right? We have to consider these two columns. Considering these two columns, we have to identify whether both are 0. If both are 0, the output will be 0. Otherwise, it is 1. So you can write like 1, 1, 1, 0. So this is the final result of this truth table. Sorry. With that, you can understand. With that, you can understand. This truth table is not similar to this truth table is not similar to this truth table. මේකෙදි මොකක්ද උනේ? O වෙලා not උනා. මේකෙදි not වෙලා O උනා. ඔය දෙක සමාන නැහැ. ඔක තමයි තේරුම් ගන්න ඕනේ. සමහර වෙලාවට ඔයගොල්ලන් හිතනවා අයියෝ දෙකම එකයිනේ. දෙකේම not තියෙනවා O තියෙනවා. එහෙම බෑ. කලින් උනේ O නම් එන්නේ මෙහෙම result එකක්. කලින් O වෙලා පස්සේ not එක. මේ O පස්සේ not එක. එතකොට කලින් not වෙලා පස්සේ O වුණොත් ඊට වැඩිය වෙනස්. Right? Here 1 and 000. Here 111 and 0. It is different, right? So that you need to understand. So ඒවා තේරුම් ගන්න ඕනේ. So no gate එකේදී වෙන්නේ O වෙලා not වෙන එක. හරි? No gate is first you O, then no කියන එකේදී ඉස්සෙල්ලාම O වෙලා ඊට පස්සේ තමයි not. ඒ වගේම තමයි NAND එකේදී. මේ තියෙන ඒ වගේම තමයි NAND එකේදී no එකත් අර වගේම no දෙකක් දාලා ගන්න පුළුවන්. දෙපාරක් O වෙලා ඊළඟ එක not වුණාම ඒ input තුනක් තියෙනවා. This is 3 input no gate. NAND gate also similar. See here, right? NAND gate එකේදී AND වෙලා not වෙනවා. එතකොට truth table එක මෙහෙම. First it will AND. You can see A and B, right? 0 0 0 1 1 0 1 1. So A and B, and then so that will be inverted. A and B will be inverted. Right here, first A and B, and so you can see and then not. But if you do the reverse, so you'll get some opposite results. So let's do this reverse. Where reverse means like first you have to not A not, then let's say B not. Let me add, then you say A not and B not. So this will not be the same. So A not will be 0. Sorry, 1 1 0 0 1 1 0 0 and B A not, then B not will be 1 0 1 0, then AND. You know the result of AND gate, the A and B, A not B not. When you AND, if both are 1, it is 1, otherwise 0. So this will be the final output. So here you got 0 0 1, but here you got 1 0 0. So similar to, this is NAND actually. This is NAND, NAND NAND gate, and this is not NAND gate. NAND gate, first you can see AND, then not. But this is not NAND, so this is called inverter AND. actually. This is not NAND, this is called inverter AND. But this gate is not there in your syllabus. But so better you know this. What will happen if you AND not first and then AND? So that is not the same. That means you can say A and B not is not A not and B not. These are not similar. Otherwise, you will think both are similar. No, this is not similar to this one, right? But there is a similarity. That similarity also you have to understand. So you got 1,000 in 1,000 in no gate. Then you can tell something like this. එහෙනම් ඔයාලට මෙහෙම කියන්න පුළුවන්. A or B වල මුළු එකේ not. වලින් ආවේ 1,000. That is similar to A not and B not. And not only that, A and B වල මුළු එකේ not here NAND. That is 1,110. No. That is similar to A not or B not. So this is what you have to. So, but the sign. So this is O, this is AND, not the sign. This is not same, but these are similar. These are producing similar. So this is called, happening like this is called De Morgan's law. මේව ඔයාලට මෙතනදී ඉගෙන ගන්න නෑ. De Morgan's law කියලා කියන්නේ මේ ආපු මේ උන දෙයට. ඒ කියන්නේ AND gate එකෙන් OR gate එකෙන් හදන circuit එක OR gate එකෙන් හදන එකට සමාන එකක් AND එකෙන් හදන්න පුළුවන්. OR gate එකේ පස්සේ not කරා නම් AND gate එකෙන් කලින් not කරා. මෙතනදිත් එහෙමයි. AND gate එකේ පස්සේ not කරා නම් OR gate එකේදී කලින් not කරන්න. These gates will be similar. That is what De Morgan has said. Okay. I think we have come to end of the discussions today. Plus, please go through. So I can see you have forgotten everything. So that is really tiredful to me. Cannot help anyway. Please give a try. Don't forget the things that you have learned. You have practice and apply. Let's discuss the remaining things next day. Good night.
Good night, sir. Thank you, sir.
Good night, sir. Get well soon.
Thank you, sir. Good night, sir.
Get well soon, sir.